All right, so we're diving into some pretty fascinating stuff today, huh? Heart failure.
Yeah, definitely. Uh, it's a topic that a lot of people, I think, want to understand better.
Yeah.
It's so central to health.
Yeah, for sure. And you've sent me some really, really great material here.
Good stuff. Yeah.
Like I'm excited to kind of break this down and I think for our listeners too, like just getting a clear picture, of how the heart works
Right.
and, what happens when things aren't working quite right.
Yeah, and there's a lot out there on this topic.
Yeah.
But I think our mission today is to kind of distill it down
Right.
to the really essential, need to know stuff.
Yeah, absolutely. Like not get lost in the weeds, but actually be able to walk away and be like,
Yeah.
okay, I understand like the basics of what's going on.
Exactly.
So to that, I mean, we've got these two major categories, right, of heart failure that we want to unpack.
Yeah.
Left-sided and right-sided.
Right.
And the material sort of, really emphasizes how different
Yes.
those two things are
Very different. Yeah.
in terms of what's actually happening in the body.
Yeah.
So maybe let's just dive right in with left-sided heart failure.
Okay.
So as I understand it, and correct me if I'm wrong, but this is essentially when the left side of the heart is having trouble
Right.
pumping blood effectively
Yeah.
from the lungs out to the rest of the body.
Exactly. Yeah, it's that left ventricle, that main pumping chamber
Yeah,
that's supposed to be, sending that oxygen-rich blood out
right.
to all of the tissues and organs.
Yeah. So then what happens, like what are the immediate consequences if that's not happening efficiently?
So basically, the blood that should be moving forward starts to back up,
Right.
and it backs up into the lungs,
Into the lungs. Okay.
into the blood vessels of the lungs. Yeah, so it's like,
Oh, yeah. Got it.
a traffic jam.
Yeah.
If the cars can't move forward, they start piling up.
Right.
And in this case, the cars are the blood cells.
Yeah.
And the highway is the pulmonary circulation.
Makes sense.
So you get this buildup of fluid in the lungs,
Yeah. Okay.
which we call pulmonary edema.
Pulmonary edema. Okay.
And that makes it really hard for oxygen
Yeah.
to get from the air sacs in the lungs into the bloodstream.
So that's where we see that kind of hallmark symptom.
Yeah.
Difficulty breathing.
Difficulty breathing. Yeah,
Yeah.
dyspnea.
Dyspnea. Okay.
So that feeling of shortness of breath.
Right. And it can be really, I mean, I know from the material, it can be really quite serious.
Oh, yeah, it can be very severe.
Yeah.
And people often notice it, especially when they're lying down,
Right.
because then the fluid kind of spreads out more evenly in the lungs.
I see.
And that's called orthopnea.
Orthopnea. Okay.
So shortness of breath when lying flat.
Got it.
And then you can also get, a cough,
Well, fair.
sometimes with frothy sputum,
Oh, wow.
which is basically air mixing with that fluid
interesting.
in the airways.
Okay.
So those are kind of the real telltale signs.
Yeah. And it's interesting because the material also talks about things like fatigue
Right.
and decreased urine output, which maybe aren't as obvious.
Yeah.
So how are those connected to this left side heart failure?
Well, the fatigue, makes sense if you think about it.
Yeah.
If your body's not getting enough oxygen,
Right.
because that left ventricle isn't pumping efficiently,
Right.
your tissues and organs just don't have the energy they need.
They're not getting the fuel they need.
Exactly.
Okay.
So you feel tired all the time.
Yeah, that makes sense.
And then the decreased urine output,
Yeah.
that's related to the kidneys.
Oh,
Basically, when the kidneys sense that the heart isn't pumping well,
right.
they try to conserve fluid
Okay.
so they don't produce as much urine.
Interesting. Okay.
And then in more severe cases,
Yeah.
you might see cyanosis,
Sinuses
which is that bluish discoloration of the skin
right.
and mucous membranes.
Yeah.
And that's because there's just not enough oxygen in the blood.
Yeah. And that's hypoxia.
Hypoxia.
Yeah.
So
Yeah.
those are all signs that, things are really not working well.
Oh. Right. So it's really all stemming from that inefficient pumping
Exactly.
and then the backup of blood into the lungs.
Yeah.
Okay. So that's left-sided. I feel like we've got a pretty good picture of that.
Good, yeah.
Now let's flip over to the right side,
Okay.
right-sided heart failure.
Right.
So here, the problem is with the right side of the heart.
Yeah. The right ventricle
Yeah.
pumping blood forward into the lungs to get oxygenated.
Right. So it's not able to move that blood efficiently into the pulmonary circulation.
Right.
So what happens then? Like, where does the blood back up in this case?
Well, instead of going into the lungs,
Okay.
it backs up into the systemic circulation.
So that's the rest of the body.
Yeah, the rest of the body.
Okay.
So all the veins throughout the body
Right.
are bringing deoxygenated blood back to the heart,
Right.
to the right side of the heart.
Yeah.
And if the right ventricle isn't pumping it forward,
Yeah.
then the pressure in those veins increases.
And so then we see a very different set of symptoms, right?
Yes. Very different.
We're talking about things like swelling in the legs and ankles.
Yeah, that's dependent edema.
Dependent edema.
Basically, the increased pressure in the veins
Right.
forces fluid out into the tissues.
Oh, okay.
And gravity pulls that fluid down.
Right.
So you get swelling in the lower extremities.
So the legs and ankles.
Yeah, especially the ankles and feet.
Yeah.
And then you also get weight gain.
Weight gain from that fluid retention.
Yeah, it's all that extra fluid in the body.
Yeah, and the material really emphasizes, like, folks need to be monitoring their weight.
Yeah, absolutely.
If they're concerned about heart failure.
Yeah, because sometimes you might just notice your ankles are a little swollen
Yeah.
at the end of the day.
Right.
And not realize that that could be a sign of something more serious.
Yeah, that's a good point. Okay. There's also this term that the material uses, congestion of viscera.
Right.
I'm guessing not everyone knows what that means.
Yeah, so viscera refers to the internal organs, primarily in the abdomen.
So like the liver.
Yeah, the liver, the spleen.
Okay.
And when the blood backs up,
Yeah.
you can get fluid buildup in those organs as well.
Okay, so congestion literally means like too much stuff.
Yeah, too much fluid.
Yeah.
Too much congestion.
Okay.
And that can affect how those organs function.
Interesting.
So you might have discomfort.
Right.
Or, your doctor might see some abnormal lab results.
I see.
That kind of thing.
And then the last symptom that we see with right-sided heart failure that's mentioned is jugular vein distension.
Right.
What's going on there?
So the jugular veins are those veins in your neck.
Okay.
And they carry blood back to the heart.
Okay.
To the right atrium.
Yeah.
And when the pressure in the right atrium is high,
right,
because the right ventricle isn't pumping well,
yeah,
that pressure can back up into the jugular veins,
right,
and make them look distended.
So swollen, basically.
Yeah, swollen or bulging.
Got it. Okay, so we're seeing kind of like two very distinct pictures here.
Right.
Left-sided heart failure.
Yeah.
It's mainly the lungs that are bearing the brunt of it.
Primarily, yeah.
Right-sided, we're seeing these more systemic effects throughout the body.
Right.
Okay, so now to understand like why this might be happening, like why the heart might not be pumping effectively.
Yeah.
The material introduces a few key concepts about how the heart actually works.
Right.
Preload, afterload, contractility, cardiac output.
These are really fundamental concepts.
Yeah. So let's start with preload.
Okay.
Just in like super simple terms.
Yeah.
How can we understand what preload is?
So preload is basically the amount of blood that fills the ventricles at the end of the relaxation phase.
Okay.
So right before they contract.
So it's like the filling volume.
The filling volume, exactly.
Okay.
And one way doctors kind of assess this is by looking at the pressure in the right atrium.
Right.
And this relates to something called the Frank-Starling law.
Frank-Starling law.
Which basically says that the more the heart muscle fibers are stretched by this filling volume, the more forcefully they'll contract.
I see. So the more blood, the more stretch,
the
stronger the contraction.
Exactly, up to a certain point.
Up to a certain point.
Yeah.
Okay, and the material has this great analogy of a water balloon.
I love that analogy.
Preload is like how much water you put in the balloon before you tie it off.
Exactly.
So the more water, the more the balloon stretches,
the
more potential it has to give a good squeeze.
Right. So it's like the heart is loading up with blood.
Yeah.
And that load determines how much the muscle fibers are stretched.
Right.
And that influences how strongly they can contract.
Okay, that's a great way to visualize it.
Yeah.
All right, so then next we have afterload.
Okay.
And how do we define afterload?
So afterload is the resistance that the ventricles have to overcome to actually eject the blood out.
Out of the heart.
Yeah, out into the circulatory system.
Okay.
So for the right ventricle, that's the resistance in the pulmonary arteries.
Right.
And for the left ventricle, it's the resistance in the aorta.
Got it.
Which is the main artery carrying blood to the body.
Right.
So the higher the afterload, the harder the heart has to work to pump.
I see. Okay. And the water balloon analogy works here too.
It does.
Right.
It's perfect.
It's like how narrow the opening of the balloon is when we're trying to squeeze the water out. If it's a really small opening, you have to squeeze so much harder to get the water out.
And that's like what the heart is facing with a higher afterload.
Yeah, that increased resistance.
Yeah.
Okay. And so that's why, like, in the material, it talks about things like, pulmonary vascular resistance.
Right.
Which can be elevated in certain conditions.
Yeah.
And that increases the afterload specifically on the right ventricle.
Right. So it's all connected.
Yeah. Okay. So we've got preload, we've got afterload. Then we have contractility.
Okay.
Now, what does that refer to?
So contractility is really the inherent strength of the heart muscle's contraction.
Okay.
So it's the ability of the myocardium, which is the heart muscle itself, to shorten its fibers and generate force when it's stimulated.
I see. So it's like how powerfully the heart muscle can actually squeeze.
It's just a squeeze, yeah.
Okay.
And that's somewhat independent of preload and afterload.
Okay.
So, things like the health of the heart muscle itself can affect contractility.
I see.
Certain medications can affect contractility.
Okay, so it's like its own separate thing.
Yeah, it's its own thing.
Okay.
But it's all related, of course.
Right.
Because, the stretching we talked about with preload.
Yeah.
That prepares the muscle fibers.
Right.
But then contractility is about how effectively those fibers can actually shorten.
Got it.
And squeeze.
Okay, all right. So then the final piece of this puzzle, cardiac output.
Yeah.
This seems like a really crucial measure.
It is. It's kind of the ultimate measure of how well the heart's doing its job.
Yeah. So how is it defined?
So cardiac output is the total amount of blood that the left ventricle pumps out. Per minute.
Okay, per minute.
So it's really a measure of how well the heart is meeting the body's demand.
For oxygen and nutrients and all that good stuff.
Exactly.
Right, okay. And the formula for calculating this is stroke volume times heart rate.
Right.
Now, what is stroke volume?
So stroke volume is the amount of blood ejected with each beat.
With each individual beat, okay.
Yeah, and heart rate, of course, is just...
how many beats per minute?
Yeah, how many times the heart beats per minute.
Got it, okay. And the material gives us a good example here. Like, if someone has a stroke volume of 70 milliliters and a heart rate of 75 beats per minute, their cardiac output would be 70 times 75, fifth down 250 milliliters per minute.
Right.
Or 5.25 liters per minute.
That's a lot of blood.
It is a lot of blood.
Moving through the body.
Yeah, and doctors also often look at this thing called ejection fraction.
Yes.
Which is the percentage of blood.
Right.
The left ventricle pumps out with each beat.
Yeah, it's another important measure of heart function.
Yeah. Okay.
So it all ties together.
Yeah, it's like all these pieces working together to create this pumping act.
Basically, this beautiful symphony of cardiac function.
And then just briefly, the material defines systole and diastole.
Right.
Can you just quickly remind us what those are?
So systole is the contraction phase.
Okay.
When the ventricles are squeezing and ejecting blood.
Okay.
And diastole is the relaxation phase.
Okay.
When the ventricles are filling with blood.
Okay.
So it's like a constant cycle of squeezing and relaxing that keeps the blood flowing.
Got it. Okay, so I feel like we've covered a lot of ground here.
We have.
We've really gotten a good understanding of left-sided heart failure, right-sided heart failure, the different ways that they manifest.
Yeah.
And then these key concepts of preload, afterload, contractility, cardiac output.
And that water balloon analogy.
Yeah, the water balloon analogy.
Is so helpful.
It is a really good one.
Yeah, for visualizing preload and afterload.
Yeah, for sure. So, as we think about all of this, and we think about how these different factors impact the heart's ability to do its job, it really does make you think about, what kinds of things in our lives can affect these things.
Exactly.
Like we talked about how preload is all about the filling volume.
Yeah.
So, things that affect our blood volume could potentially have an impact.
Yeah, absolutely.
Like, what we eat and drink.
Right.
How much we exercise.
Yeah.
And then afterload is all about the resistance. Yeah. So things like high blood pressure.
Absolutely.
Could really affect that.
Yeah, it can make the heart work so much harder.
Right. So as we go about our day, and we make choices about our health, it's worth considering how those choices might be impacting our heart and its ability to function.
It's all connected.
It is all connected.
Yeah.
All right. Well, I think we've done a really good deep dive here.
Yeah, I think so.
So listeners, if you want to learn more about heart failure, there are some fantastic resources available.
Absolutely.
And in the meantime, take care of your heart.
Yeah, your heart is precious.
It is.
Take care of it.
All right, thanks for joining us.
Thanks for having me.
We'll see you next time.
See you.